morning, everybody, and welcome to this online cloud coaching session. Today, I will talk about decentralized data platform and how you can design such a platform on Oracle Cloud infrastructure. My name is Jakub Illner, and I work as a data platform specialist in Oracle. I focus on data lakehouses, data lakes, data warehouses, analytical solutions, artificial intelligence, and similar data and analytical solutions that you can find in all organizations across the world. You can find me on LinkedIn. You can read my blog on GitHub, or you can contact me on my Oracle email address. Before we talk about the decentralized data platform, let's understand why we need to start this discussion. In my experience, there are several reasons why you need to consider a decentralized data platform. The first is if you have a monolithic data warehouse or a data lake, and you need to decompose the system into multiple domains. And the reason for that is that you need to achieve a better agility or better scalability of the solution. Or you are managing data in a complex decentralized organization with many units which are responsible for its own data, and you are considering data mesh as the optimal architecture approach for the data management in such organization. Or you simply have a data which are distributed across the globe, and you need to keep the data in place to meet the regulatory and the residency rules and to achieve the low latency, but you still need to have a global view across the whole organization. Or you decided to use multiple public clouds and multiple domains, which each domain is deployed in different public cloud or on-premises or private cloud, and you need to guarantee the integration and connectivity between the domains, and you need to share the data between the domains. So these are all the reasons where the decentralized data platform makes sense. So we have to look at the three dimensions of the decentralization. The first is decentralized organization, where the individual domains are owned, developed, and operated by different organizational units or even by different entities. The second is decentralized location, where the data are spread across multiple geographical regions, and you need to guarantee the data locality and to minimize the latency. And the third one is decentralized deployment, where the data are deployed and the applications are deployed into multiple public or private cloud or on-premises platforms. So in today's agenda, I will talk about the decentralized data management, about the concepts like domains, data products, and the data platform. If you know data mesh, these concepts are taken from the data mesh, which is no surprise because the data mesh is actually designed for the decentralized data management. Then I will show you how you can use Oracle Cloud as the decentralized data platform and how you can share data across domains, locations, and clouds with Oracle Cloud products. So let's start cracking. As the first step, what is the opposite of the decentralized solution? It's obviously a centralized system, and in the data management, we built many centralized data hubs like enterprise data warehouse or enterprise data lake or the organization-wide operational data store. And all these systems were located in a single place, typically in a single relational database, and managed and operated by a single team. Now, these systems, of course, they provided great value because for the first time, they centralized data in a single place and users had only one place where to look for the data. But as they grew, they actually stopped being agile. So any change to these systems required a lot of effort, a lot of time for all the regression testing to make sure that the change does not break any existing functionality. So to add a new functionality, new subject area, to change entity, it was usually quite difficult and it took many months to implement. Also, these systems, because they were managed by a single team, and these teams had to cover all the subject areas which actually dealt with many different views of the business or even different business lines. So the teams focused more on the technology than on these subject areas. They could not specialize on particular business functionality, rather they specialized on the technical functionality. And last but not least, these systems stopped scaling because once they grew to some size, they had to be scaled as a whole. You could not scale only a single area like the retail part or the retail transactions of the business. You had to scale the whole system. So that led to the over provisioning and low performance, and you had to pay more for running and operating such system. So as a alternative to decentralized system, we have what we call a distributed domains or the data mesh approach. With the distributed domains, actually you break the data management and analytics functionality into several applications, which we call a domain, and every application provides a particular business functionality to the users. These domains are decoupled so that you can develop and maintain and scale them independently on each other. So the domain and the decoupled nature of the domains is the key feature of the distributed systems. So what is actually the domain, right? You can consider a domain as a data application. So the domain typically requires some data on the input, and it produces the data. It produces a data, we call it, it produces a data product. So the data which are output of the domain, these are the data products. And of course, the data domain has to provide some business capabilities. The business capabilities could be, for example, some reports, some calculations, some dashboards, analytics, machine learning models, etc. The domain is owned by a domain owner, and it's managed by the domain team, which consists of the engineers and the analysts and the other specialists who are looking after the domain. But these specialists, this domain team is focusing just on this domain, not across all the domains. So that's the important part of the domain ownership. So we have the domain, which is with the input data, output data, and the business capabilities. And of course, the domain has some internal content, which from outside you can consider as a black box. This content is typically a data pipeline, which takes the input data, applies some transformations, the data models of the domain, the way how the data are governed and checked and published. Right? So that's the internal functioning of the domain. Now, we can think about several types of the domains. The first type is the source domain. The source domain, actually, the primary purpose of the source domain is to publish data from the operational application. Right? So the source domain is tightly integrated with the operational application, and it publishes data out of these operational applications. So the purpose of the source domain is this data publishing, right? So typically the data publishing for any consumer that needs data out of this operational system. Then the second type are the consumer domains. The consumer domains are used by end users. So these domains can, as an output can provide reports, can provide dashboards, can provide data sets for the data scientists. They can provide some logic, machine learning, or some decisioning algorithm for the operational application. So these domains are primarily consumer-oriented, and they consume data from the other domains. So they typically have a lot of data on the input, and they mostly provide the functionality to consumers. And then, of course, we might have domains which are in the middle. I call them processor domains, whose purpose is to apply some transformation and to provide the data for the other domains. Now, because one of the key principles of domains is the business focus, these domains are typically tied with the consumer domains, because it's hard to find a business owner for just the domain which does just some data processing. Okay, so we have source and consumer domains, and sometimes we have also the processor domains if there is a important and complex data processing task. Now, in order for the domains to exchange the data and still being able to be managed independently, the data has to be exchanged in a well-governed way. So for this, we have the data products. So the data products are the data produced by domains, and the objective of the data products is to share data and to actually remove the silos. And we have a couple of principles for these data products, and these principles have to be met in order to be able for the domains to talk to each other. So the data products, they have to be discoverable. There must be a data catalog with a list of all data products which can be used. We must be able to address them in a standard way and to access them in a natively accessed format. I will talk a little about this on the next few slides. The products have to guarantee some service level objectives. So if the data product provides data, for example, in real time or with some batch frequency, this frequency has to be part of these service level objectives. The way how the data model can change or how the data shape of the data can change must be part of the service level objectives. The data quality has to be part of the service level objectives. Now, of course, the data products have to be documented, and there must be some interoperability principles and rules in place so that you can be sure that all the products use the same identifiers, same metadata, etc. And last but not least, the data products have to be secure. So not everybody can access every data product. Of course, this has to be governed. So users of this system have to be properly authenticated. The data have to be secured by the access control and protected by other means according to this to their classifications. Now, what can you imagine what do I mean by natively accessible data products? So the data products have to be reached through the standard APIs. So for example, if the nature of the data product are the streams, then the API probably would be a Kafka compatible API. So any Kafka consumer can read data from this data product. Or if you are producing data sets for data science, for example, the data might be accessible through the S3 API, which is a de facto standard for the object storage. Or the data might be accessible through REST API, again, next standard, or through SQL using JDBC or ODBC connectivity, as this is a de facto standard for connecting to the relational databases. Or there might be other standards which are now widely used. So OpenSearch API for the search functionality, new data formats like Apache Iceberg or Delta Lake, which are the data formats for large analytical tables, or the Delta sharing protocol, which is now used for the sharing of the data between different technologies, between different clouds, using the Delta sharing protocol, which was developed initially by Databricks. So all these are possibly the natively accessible data products. Now, when you are building these data products and the data domains which are behind the data products, they should be built on the data platform. So the objective of the data platform is actually to provide functions so that you can build these products. You can build data integration components, data management components. You can provide analytics, self-service capabilities to the users. But it's not only that. The platform has also to provide the common security, governance, management, observability, and automation capabilities, which has to be used by all services. Because although the domains are decoupled, we still need to have one view, one way how to see what's going on and to ensure that the data are secured and the proper access control is employed. The data platform must be available as a self-service because the individual teams responsible for the domains have to use this self-service data platform individually. They should not need any assistance or support from the centralized team. And also, the data platform must support building decentralized and decoupled data products. So it should not be a data platform which is in the single place. The platform should be actually decentralized as well, so that these data products can be decentralized. Now, example of such data domains, and I will use this example when I will explain how you can use OCI as a data platform, is this simple case of a manufacturing organization, which has, for the simplicity, just two analytical use cases. The first one is that they need to have analytical dashboards and self-service visualizations to look at the things like what assets they have, what machines, equipment types, sensors, what are the locations, status of these sensors, what is the current performance, operating conditions, etc. So basically, analytics on top of the manufacturing data. And then they would like to proactively monitor the devices and the machines in the manufacturing plants to be able to project if there is any probability of failures or of a deteriorating performance of the quality of products. So two analytical use cases. The first one is dashboards for users. The other one is the proactive monitoring of the output to be able to predict failures or issues in the production. Now we can model this as 4 domains, which 2 of them are source oriented. 2 are consumer oriented. So one source domain contains the data about assets, basically a master repository of what is the equipment, devices, sensors, machines, etc. What is the location, what manufacturer, model, etc. All the information about the devices used in the plants. The second source domain contains all the readings, all the events, observations, status changes, and other events that are produced by these plants. And we have two consumer domains which correspond to the analytical use cases. So one consumer domain, let's call it manufacturing analytics with the data mart, dashboards, and visualizations. And the second one, which I call condition monitoring, which contains machine learning models or predictive models, which are looking at the sensor readings, characteristics of the equipment, and they try to predict failures and notify users and maybe some operational applications like the maintenance systems. Okay. So that was about why we need a decentralized data platform and the decentralized capability. Now let's have a look at how this can be implemented with Oracle Data Platform. And what I mean, Oracle Data Platform on Oracle Cloud Infrastructure. So that's Oracle Cloud Infrastructure is quite a rich ecosystem of services. And of course, these services can be used for all kinds of data management and analytical solutions. So for the data integration, operational data store, data lakes, data warehouses, analytics, development of data applications on top of that. And many services which are used for governing, securing, and improving or monitoring performance of these services for Oracle Data Platform. Now, Oracle Data Platform, which is Oracle Cloud Infrastructure, can be deployed in the public cloud. We have a sovereign cloud for EU customers. Large customers can consider dedicated cloud regions. And recently, we have also introduced Cloud at Customer, which together with the Exadata Cloud at Customer provides the smallest, I would say, public cloud and customer premises where you can deploy the services. So you have a variety of deployment options. And of course, you can combine Oracle Cloud Infrastructure with the other public cloud and multi-cloud scenarios. And Oracle Data Platform can consume data from all kinds of applications like Oracle SAS and other Oracle applications, third-party applications, IoT, social media, web pages, etc. And it can be used for a variety of use cases like dashboarding, providing real-time business insight, understanding the performance of your organization's efficiency, etc. Okay, so that's the introduction of the data platform. Now, Oracle Data Platform on OCI is, of course, distributed across many cloud regions. You can see the distribution on the map. So we have many regions across Europe, Americas, EMEA, and Asia. So for globally distributed organization, you can always find a cloud region near your location and deploy the data application there. Okay, so how you can use the Oracle Cloud as the decentralized data platform? So there are a couple of, I would say, principles or guiding rules that you should apply. The first is the common identity access management for all domains and all data products produced by the domains. And related to this is actually using the groups and dynamic groups to assign the users to the access rows which they have in this distributed data domains. Then to decouple the domains to ensure that the domains do not have anything in common, to use separate compartments with the policies, and to use different networking with different virtual cloud networks. And so these compartments and the different VCNs, they ensure the isolation of the domains. But of course, we need still to have the common visibility of the data products across all the domains. And for this, we have the common data catalog. And so once you have this setup in place, then you can develop and deploy domains in OCI regions for different different business functions, or you can do this across multiple clouds, including OCI and other clouds like Azure or AWS. Okay, so let's have a look at these rules. So common identity and access management is critical because when we are designing the access control rules, we have to apply this across the whole user base. So every user of this distributed platform has to be authenticated by the same means, by OCI IAM. The agents, the automated services like, for example, ETL service or monitoring service, we have to use the dynamic groups. So they are authenticated using these dynamic groups. Now, the OCI services are, of course, out of the box integrated with OCI IAM. So I would say this capability is automatically available. However, there are services where the users, where you might need to take some additional steps so that the users are actually authenticated by OCI IAM. So, for example, Oracle REST data services, or the database users is in Oracle Autonomous Database. Okay, and of course, you do not have to use OCI IAM as the master identity provider. You can use a third-party identity provider like Azure Active Directory if you wish to do so. Okay, so the common identity access management. Now, before we can provide access, we have to define the groups and the dynamic groups. So, as I would say, kind of minimum setup for the groups, we typically need an administrator group for every domain. So the administrator group is responsible for managing all resources in the domain. Then we need a data ops group. The data ops people are responsible for development and operation tasks in the domain. So for managing the data integration, managing the databases, managing the BI components, and then we need also the group for users of the domain. Okay, so three as a minimum, three groups of users: admins, data ops, and users. Now, for the agents, we need at least one dynamic group, and this dynamic group will contain all the agents that need to manipulate data in the domain, work with the resources in the domain, basically for all the automated stuff that is happening in the domain. And you can see on the picture that actually this is true not just for the domain, but it's actually true for the data platform itself, because the data platform has to provide also these common services. So, for example, to manage the data catalog, we need also the agents and groups for the management of the data catalog. Okay, so this is the way how you can think about the groups and the dynamic groups. And to isolate the resources into domain, in OCI we use compartments. So compartment groups all the resources which belong to the same category, and in this distributed or decentralized data platform, the category actually is a domain, right? So all the resources in a domain should belong to a single compartment, right? So in the compartment, in the example which I have explained at the beginning, we have one master compartment for this data platform, and then we have one compartment for the asset management, for the sensor readings, for manufacturing analytics, and condition monitoring. And these these compartments are managed by the administrators of the domain, and the data ops personnel and the users and the agents, they are provided policies to be able to work with the resources in the domain. Okay, so the policies have to be defined for each and every group. Now, I will not go into detail what we have to provide, because I provided just some example for managing the object storage or OCI data integration, OCI data flow, or autonomous database, but this will really differ depending on the mix of services that you need to use. So for every domain, we will need the administration policy, we will need the data ops policy, the agent policy, and the access policy for the users of the domain. Of course, the policies should contain as small number of rules as possible. So typically, to manage all resources is probably not the best way to do that, but of course that depends on what kind of services you will be using. Okay, so with compartments and policies, I have shown you how you can isolate the domains regarding the management of resources. But of course, the domains need to exchange the data, so you also have to control the traffic between the domains. And the traffic is controlled through the OCI networking. And to ensure that the traffic between domains is well controlled, I would suggest that every domain is placed into a different VCN, virtual cloud network. It might be possible to use just subnets, but I believe that VCNs provide a better control. So I would prefer to use different VCNs than subnet. So in the example here, we have a data platform which is distributed across two data centers, Frankfurt and Amsterdam, and the asset management and sensor reading domains are placed in the different VCN in the Frankfurt, and manufacturing analytics is in the Amsterdam region. Now, with this setup, we need dynamic routing gateways to actually provide the connectivity between the VCNs, between the domains, and we can also establish the remote peering connection for the connectivity between the domains which are placed in different regions. And we also need the firewall rules. The firewall rules in OCI are implemented through the security list or network security groups, or alternatively, you can use a centralized network firewall. And of course, there have to be also the DNS record so that we can address all the resources using the fully qualified domain names. Okay, so we need also the traffic isolation by the means of using different VCNs. Okay, so we talked about how to isolate domains from the management and traffic point of views, but what we need in common is the common data catalog. So the common data catalog is a single data catalog instance where you can search for all the data products, and this instance should contain assets from all the domains which have to be published. So for every domain and every data product, there should be one data asset describing the data product and the important attributes of the data product, so that users and developers and analysts can go and see what data products are available in the system. Okay, so once we have this in place, so we have the groups, we have compartments, policies, we have the networking, we can start developing and deploying the domains in OCI. And of course, this is just example of the services that we can use. So for example, the asset domain could consist of the data transforms in the autonomous database and autonomous database to store the master asset data. The sensor readings, because it deals with the real-time data, with the events, can use API gateway and functions to onboard these events. OCI streaming with the streams of data coming from a different location, and we can provide these streams either directly or we can materialize them into object storage for the future analysis and as an archive of events. The manufacturing analytics can contain another autonomous database instance and the Oracle Analytics Cloud for the dashboarding and visualizations. And the condition monitoring could contain stream analytics, which is the event processing engine, and the anomaly detection engine to find out the anomalies. And it may use notifications to notify the users about the detected issues. But of course, that's just an example. Your domains will look differently. And before we go to the data sharing, I would like to also highlight the fact that what I explained in OCI can be actually spread across multiple clouds. So we have quite strong multi-cloud capabilities. For example, with Azure, we have interconnect between Azure and Oracle Cloud Infrastructure, which you can easily use. And you can use it, for example, by building domains which implement what we call a split stack scenario, where the domain consists of components which are deployed in different clouds. And in this example, the domain uses autonomous data warehouse in Oracle Cloud Infrastructure, which is being accessed by Power BI from Azure, using the same, of course, the same geographical region, which is the Germany Central in Frankfurt, where both OCI and Azure have data centers, and the interconnect, which consists of Fast Connect and Azure Express Route, is there to ensure the low latency and good bandwidth between these two clouds. Or you can also use this across multiple domains. It does not have to be split stack. It can be in the domain to domain integration scenarios, where each domain is deployed in a particular public cloud, and the interconnectivity is used for the data sharing between the domains, in this case by using the delta sharing protocol, which is part of the autonomous data warehouse and which can be used by Databricks or Power BI and Azure to access the information published from the data warehouse. Okay, so that was about the decentralized capabilities of Oracle Cloud Infrastructure. And in the last part of this session, let's have a look how you can easily share data from within OCI products. And I will look at these 5 options, but of course there are many others, right? These options are just the ones which are most often used, or which I have seen most often used. So let's have a look. So the first one is simple sharing of data, data sets, I would say, across domains or locations or clouds using OCI object storage. And the principle is very simple. You have some data, you publish the data into object storage bucket. You use a data format which is well understood by most consumers, like Parquet or CSV or JSON files, and you provide the data through the OCI API or through the S3 compatible API. Now, these data can be consumed by almost any type of application, whether it is OCI service or whether it is third party or open source or other cloud service. Now, this access, of course, requires authentication. So, as you know, with any data that is published, the authentication is mandatory. The authentication can be done through pre-authenticated request or through the tokens or other means of how OCI-IAM authentication can be provided. So this is for the data sets which you might use for example, for data science scenarios. The second example is sharing streaming data. Now, the standard streaming protocol is Kafka, as we have seen already. So in OCI, we have OCI streaming service, which is the managed service for managing the streams. OCI streaming provides a Kafka-compatible API, or you can use also Kafka Connect clients with OCI streamings. So that's the way how you can publish the streaming data. And again, all the services, whether they are OCI services or third-party or other cloud services that can consume Kafka, Kafka services can work with OCI streaming. So that's also a nice way how you can publish the data across domains, across clouds in a controlled manner. And of course, authentication is required as well. Now, the next way how you can share the data is providing the SQL endpoint. The SQL endpoint can be provided, for example, via autonomous data warehouse. So the data which is available in the autonomous data warehouse or autonomous database, in the relational tables or in a JSON collection, can be accessed over the SQL, over JDBC or ODBC using SQLnet. And almost any type of service can use this type of connectivity. So like Analytics Cloud or Power BI or Databricks or ClickView or Tableau, all these services and technologies can access the data. Now, when you use when you share the data by providing the access directly to autonomous database, of course, you have to be aware that the queries are actually running on the autonomous database. So any consumer of the data will place a load on your autonomous database. Now, another way how you can publish data out of the autonomous database is, instead of providing direct SQL access, you can kind of restify your data. So you can build a REST interface on top of your data and provide not SQL access to the data, but REST access to your data. So that's a recommended way if you would like to provide some kind of online services like online queries where you expect a lot of consumer, a lot of concurrent requests. You have to keep the good performance, the very low latency. So the REST data services, it's a managed part of the autonomous database. Of course, you can deploy it also as a customer managed solution, but just by deploying autonomous database, you get REST data services out of the box. Okay, and the authentication mechanism of Oracle REST data services can be also integrated with OCI IAM. And last but not least, autonomous data warehouse also supports delta sharing. So the delta sharing is a protocol which was introduced by Databricks. And the purpose of the delta sharing is to be able to share data between heterogeneous components. So you can use it to share data, for example, from autonomous database to Databricks, or from autonomous database to Power BI, or autonomous database can consume delta shares from other data providers. Now, when this delta sharing is implemented with autonomous database, the consumer of the data do not access directly the autonomous database. Rather, the data is provided as data shares into object storage, into Parquet formats, and the consumer domain accesses these data shares. Now, the authentication is provided via the delta sharing server, which is also automatically provided out of the box with the autonomous database. So for the heterogeneous multi-cloud scenarios, this might be quite interesting approach. Okay, so we are getting to the end. So as a summary, you can use easily and securely Oracle Cloud Infrastructure as a decentralized data platform. The key principles for using that is using the identity and access management and OCI for all the domains. By defining groups and dynamic groups for every domain so that you can control the access across the whole environment. You need to isolate domains by placing them into separate compartments and to define the policies which are scoped by these compartments so that the management and access to the resources is well managed. The data traffic between the domains should be controlled by placing domains into different VCNs and by establishing the firewall rules so that only the allowed data traffic is possible. Now, to ensure the common visibility of all products across the domain, you should implement a single data catalog. And once you have this set up, you can develop and deploy domains on OCI, or you can develop and deploy domains in OCI and the other cloud in one of these multi-cloud scenarios. And to effectively share data between the domains in OCI, you have many choices, but the most frequently used choices are using object storage with S3 compatible API for sharing the data within and across the clouds, using the OCI streaming with Kafka compatible API for providing the data outside as a stream to the other domains that need streaming data, or using autonomous database with either direct SQL access using ODBC or JDBC, or with REST access, or with the new Delta sharing capability, which will allow you to share the data between multiple technologies and multiple clouds. Now, I hope this information was useful for you. And I would like to bring your attention to the other cloud coaching sessions, which you can find on Oracle web, and which are provided either on demand as this session or online. So many thanks for watching this cloud coaching session, and I hope you will have a look at the other sessions soon. Goodbye.